Alright, so today our problem we're given a retirement savings decision where our financial advisor is 22 years old, making $65,000 a year, plans to retire at age 65, save 30% of income at the end of every year. We expect inflation to be 2% a year and an interest rate to be increase 5% every year. We also expect the salary to increase 3% every year, and we suggest him to invest 60% in the saving and stocks and 40% in the bonds. And we expect a stock return of 8% per year and a bond return of 4% per year. So we're trying to figure out what this would look like over that 43-year span. So we're going to be using all these formulas like to find present value. We have present value obviously equals C or our cash flow in the future. Um, so that could be like the next period if it's CV1, CV2, would just keep going. And then the number of periods until the cash flow is received. So we'd have to do this over and over and over and add all the values up to find the total present value at the end. Um, so for starters, the C would be like, pretty sure it said 19,000 is our cash flow somewhere. Yeah, 19,500 would be the amount we're putting aside to save. Um, so I'm pretty sure that would be our first value. And then our discount rate or the interest rate, I think, was 6.4 because we were taking, yeah, 6.4% because 4.8 you see is from this in the bonds, 60% of the stocks, 8% return, and then the bonds would be 1.6. Add those together, and you get 6.4 as our interest rate. So that would be how we find present value. Um, and then for future value, that's kind of like the present value, sort of like our nest egg, like main chunk, um, where our main chunk of money's going. Future value is just the total value at the end that we should be holding at retirement. Get this, we use our present value and then we multiply that 1 plus I, which is just the interest rate. So again, we're using that same rate as before, and then the n number of periods, which I forget if I said that before, but that's just number of periods until the cash flow. So it'd be like 43 and 42 and so on. We'd have to add all those up to find the values for the different periods or the total at the end. Um, so you can see some of the math here, you 9,500. So if you add all those up, we finally see that our future value at 65 would be approximately $6,262,940. It's a lot of money. It's a good retirement, in my opinion. And the present value we see is obviously less than that, 768, 487,000. So we just use those formulas, add them up every year to get these values. That would take a long time to do offhand and on hand or to display. So that's why we do this. Use some AI to help us out, but we know how the process goes. So then, kind of looking at this, we have our alternative plan. Um, so I see that the return on stock seems to be higher than bonds, so it would make more sense to put more money into stock. So we see it suggests a 90 to 10 ratio between stock and bond. So more money into stocks. See that here. So the new weighted interest rate would be 7.6. So it seems like our value should be higher. And it actually increases our future value 2,122,000 over time, which is insane. Nearly 34% increase from the original plan to this final value in the 8 millions, which is ridiculous. So this plan is a lot better for retirement. But we use the same process. We just switch the percentage we're putting into stocks versus bonds, so that would change our interest rate value or rate value, whatever you want to call it. So then the last thing they want us to do is impact of saving an extra $1,000 per year. So we go back to the original plan with 6.4, the same distribution of 60% stocks to 40% bonds, and do the same process. And we see that the additional $1,000 would grow our future value in the end, $211,015, which good amount more at the end, an extra 211,000 for retirement. So that's pretty good. I mean, in the grand scheme of things, it doesn't seem that big for the final value, but it definitely helps out. So yeah, adding that extra money helps, and thank you.